Hello class, this is Will McBurney here. I wanted to walk through some of the common questions I've seen regarding delete. So let's start with deleting a node that has no children. Let's say, for example, that you wanted to delete, in this case, we wanted to delete, say, the node 1 right here. So this is the node we're going to try to delete. The way we're going to do that is we're going to create a variable to go through the table called t. I'm using green boxes for my, actually I'll use not a green box, but a orange box for local variables, green being instance variables. So the only instance variable we have right now is root. I'm then going to set t to be equal to root. Now when I say that t equals root, and let me correct that. When I say t equals root, understand that what it means is that t points to the same node root points to. But modifying t does not modify root in this case. So we do not want to modify root. We only want to modify a node that we're going to delete. We're going to use t. Now, from here, my first step would be, okay, I need to find node number 1. So I'm going to say, okay, is 1 less than or greater than 5? Well, it's less than it. So I'm going to come down to 3. And then have I found 1 yet? No, I haven't. So then I'm going to say, okay, well, I need to go down to the left because 1 is less than 3. And look, I found 1. But here's the thing. I actually can't delete this node from here. You cannot just simply say null because this is not a binary search tree anymore. What is less than or greater than null? It doesn't make sense. So that's not a valid solution. So instead what we want to do is while we're up here at 3, we want to look left and say, is the node to the left? That is t dot left in this case, and the reason I say dot left is I know I'm looking to left, is t dot left 1? And in this case, it is. So at this point, I can say, okay, if t dot left is 1, I need to delete t dot left. And the way I can do that from t is I can simply say t dot left equals null. Or t, in this case, based on the way we gave it to you, t dot set left null. And that's it. At this point, if I say t dot left is null, that link gets deleted, and t dot left is now pointing to nothing. It's pointing to null. And this node will eventually get deleted by Java garbage collection. So the way you delete a node is from the parent. Now that's an easy case. That is where the node has 0 children. Let's consider a case where we're deleting a node that has 1 child. Let's delete the node 15. Now in this case, starting the same, I'm looking for 15, and I'm going to say, okay, 15 is greater than 5. Is t dot right 15? And it's not. So because it's not the value I'm looking for, but I need to traverse down that path, I will traverse, and t will become, and I'll just move this over here, t dot 12. Now I look and I say, okay, t dot right, we delete that, not relevant anymore, t dot right, is it 15? And in this case, it is. But the difficulty here now is while I'm looking at t dot right, I notice that, oh wait, but it has 1 child. Now in this case, it actually doesn't matter if it's a left or a right child. All that matters is it has exactly 1 child. And because it has 1 child, excuse me, I have this at the wrong point, what I need to do is if I do what I did before, which is I say t dot right equals null, and I delete this link, now notice I didn't just lose 15, I also lost 17. And I don't want to do that. I don't want to lose 17 from the list. So instead, because I recognize that the node I'm deleting has a right child that I don't want to delete, and because it only has 1 child, effectively what I want to do is have t adopt its grandchild. I want to have t adopt its grandchild by saying the following in this situation, and I'm taking advantage of the fact that 15's right child is 17. I will say t right equals t dot right dot right. That would be one way to say it. Another way to say it would be t dot set right equal to t dot right t dot get right dot get right. Right, and that's not the prettiest thing to write, admittedly, but that is effectively what I would be doing here. Now, what if instead of this being 15, let's say this were 14, and by nature of being 14, it were a left child? The only change I make at that point is to say get left. So when I'm looking at the grandchild, I need to know, is it a left or a right child? Now let's move on to the fun examples. And this is where we're seeing a lot of trouble. Let's say I want to delete the node 8. So at this point, starting the same, we start at the root, we're looking for 8. Actually, let's delete the node 12. That's a bit more interesting an example. Let's delete the node 12. So if I'm going to delete the node 12, the first thing I'll notice is obviously the root is not 12, but root.right is. So t is currently here, and t.right is the node I want to delete. Now, the problem here is it's difficult to delete this node because it has 2 children. So we're actually going to cheat a little bit. We're not going to delete this node. And you may be thinking, wait, but don't we need to? Well, here's what we're going to do. I'm going to create another variable. Let's call this D. This is D for the node to be deleted. And I'm from here going to find the successor node. And the way you find the successor is first you go say D equals D dot right. And then you keep going D dot left until you can't go left anymore. The idea is 15, the right child of the node we're deleting, is a subtree. We are going to find the smallest value in the subtree, and we do that by just saying d.left.left. And once I find a node that has no left child, I'm going to say, okay, from here, this is the successor value. And rather than delete this node, I'm simply going to copy this value, 14, up here. And I'm going to just say t.right.setData 14. From here, now the node that I delete is 14. Now there are 2 possibilities here. The first is that 14 has no children. If 14 has no children, then I simply just say, okay, go to the parent. You could have another variable keep track of parent, or you could just say you have D loop through until D.left has no left child. Either way, from the parent, just say this dot left is null. And from here, this node gets disconnected. Eventually, Java collection comes along and deletes it. The other possibility, though, is that D has, and in this case, let's just create another node, that D has 1 or more right children. It has 1 direct right child, but it may have indirect right children. And let's just say 14.5 here. Little bit ugly. There we go. At this point now, if this node has right children, we do the same thing we do when we delete one node. We simply say, and if D is the parent, D.left equals D, or D.left, set D.left to be D.left.right. That will make the left child be 14.5. This node will go away, and just to move that node to make it more clear it's the left child, that's the end result. That's the hard case. But notice I didn't really delete this node so much as I overwrote it and deleted another node. It's hard to delete nodes that have 2 children. It's much easier to delete nodes with 0 children or 1 child. From there, let's consider the last example. Let's say that this is my tree. And so I have an unbalanced tree here, but that's fine. And let's say I wanted to delete the node 5. Now the obvious end result is just going to be, since 5 only has one child, we delete it. Except now I have a problem. And the problem is my root is not pointing to anything. In fact, how do we delete this? In order to delete the node 5, it's actually a special case because 5 is the root. What we do to delete the node 5, since it only has one child, is we just say root equals root.right. So root, which was this node, is now equal to this node's right child. And look at that. The reason 5 gets deleted is there's no variable pointing to 5 at this point. And so because there's no variable pointing to 5, Java garbage collection grabs it, and hey look, we have a binary search tree and we've deleted 5. The last example, and I've seen confusion on this. How do we delete this node? We simply, in this case, if we say delete 5 and this is the only node in the tree, we simply say root equals null, and it will get deleted. So best of luck on this assignment. I just wanted to give you some visual aids. I hope you find this helpful. Thank you for watching.